So with the help of these two formulas, we can calculate the net buoyancy force and we can calculate the point through which the buoyancy force is applied through. After knowing the buoyancy force, we are going to discuss the equilibrium of submerged body. Submerged body means, suppose this is a body which is fully submerged in a liquid, like if submarine is going inside the sea, when it is fully submerged. In that case, if we want to discuss the stability, then what are the conditions of the stability, we are going to discuss through these few figures. In the first three figures, we have a body which is fully submerged. In figure A, which is fully submerged in a liquid. Now the body is having G here, and G means center of gravity, which is function of the mass distributed in this body, and B is function of the shape of the body, and it is basically the buoyancy point or centroid of displaced volume. With reference to body, the G and B remain fixed for fully submerged body. Through B we have a buoyancy force in upward direction, and through G we have a gravitational force, which is weight of the body in downward direction. When FB and W are same, then this body will remain in this position and it will not go down, it will not go up. Now because of some external force, if it gets tilted and it takes this position, second figure B, if it takes this position because of some external couple, then what happens to B and G? The position of B and G with reference to body remain fixed, because the shape of the body is fixed and its mass distribution is also fixed. Now through B we have a buoyancy force acting upward, and through W we have a weight acting downward. Now these two forces are not acting through same line, so they will make a couple. What is the couple? Couple is equal to FB is equal to W. So either we take FB or W multiplied by this perpendicular distance between these two lines, these two parallel lines. So these two forces will make a couple, and this couple will act in this direction, which is shown here. This couple will act in this direction, in the counterclockwise direction, and its magnitude will be equal to FB multiplied by this parallel distance between these two forces. So in that case, as soon as that overturning couple, because of which this gets tilted, goes, then this body, which is fully submerged body, will come back to original position because of this restoring couple. This couple is known as a restoring couple. Now similarly, if we have a overturning couple, because of that this body takes this shape, because of the couple acted on this body in the counterclockwise direction, right. Because of that the B and G will form a couple. Through B and G we have a forces acting in upward direction and downward direction. They will make a couple which is acting in a clockwise direction, this direction. It is shown here. This couple is known as a restoring couple. So as soon as that overturning couple, which was applied in this direction due to some external pressure, force, it may be due to the wave, it may be due to the some force applied from the outside, or it may be due to some weight moves from here to there. But when weight inside the body moves from one location to another location, it will disturb the G also. Okay, but that disturbance may not be great one. So that's why we are taking that G remain fixed. Now because of this overturning couple which is applied on this body in this direction, because of that this body takes this shape, and as soon as this couple goes, because of this restoring couple, this body will take to original shape. So this type of equilibrium when the body has tendency to come back to original position is known as a stable equilibrium. Now we may have another kind of equilibrium. So in first case, when B buoyancy point is above the G, in that case we have a body which is said to be in stable equilibrium condition. Now we may have another situation where G is lying above B. In this case, when G is lying above B, what happens when it gets tilted? Let's look at this figure. When it gets tilted due to some overturning couple, in this case what happens? Buoyancy point is B. Through B we have a upward force, and through G we have a weight acting downward. Now this force W and FB, they will make a couple which will turn this body in the clockwise direction. So we have a overturning couple in a clockwise direction, and we have a couple which is produced due to the shifting of the position of B and G due to the overturning couple. Now both are acting in same direction, so that's why even there is slight tilt, just few radians in the clockwise direction or counterclockwise direction, in that case a couple produced because of the force applied through G and B will also make a couple in the same direction, and this body will keep tilting till it takes the new equilibrium position. So that's why this type of equilibrium, when the body does not have the capability to regain its original position after the removal of the external couple. In fact, in this case, if this body gets tilted slightly, then a further couple is formed due to the force being applied through G and B in the same direction, and this body will keep tilting till it takes new equilibrium position. So that's why this type of body is known as unstable equilibrium condition. When G is lying above B, this body is in unstable equilibrium condition. So when we want to design some engineering product like submarine, which is fully submerged in a body, fully submerged in a liquid, then we have to be careful about its stability. So for that we must design in such a manner so that G always lie below B. Even if we have to move some mass from one location to another location, then we know that G is function of mass distribution in the submarine, which is carrying missiles, etc., people and liquid fuel, etc. So for that, and which is being consumed, we must ensure that G always lie below the buoyancy point to have a stable equilibrium condition. So then we may have a third situation when G and B both are lying at the same point. If we have this kind of submerged body where G and B both are lying at the same point, in this situation, if this body gets tilted, then no couple is formed because of the force being applied through G and B, because both are acting through same point. So this body will remain in that disturbed condition due to the externally applied couple, and it will not, even if that couple is removed, it will not try to regain its original position because no restoring couple is formed, being the force applied through same point. So like if you look at the balloon, spherical balloon or football, where CG is lying at the centroid and buoyancy point is also lying at the centroid, both points are same. If we tilt this football or balloon, it will remain in that position. But suppose if we have a kid's equipment, we may have seen where G and B are not at same position. In that case, what happens, if we displace that equipment, it will come back to original position because G is lying below the B, right. Now we have summarized these three scenes stable equilibrium, neutral equilibrium and unstable equilibrium with the help of these three figures. So, for stable equilibrium of the fully submerged body, the B must be above the G. For neutral equilibrium, both G and B lie at the same point, and for unstable equilibrium, when G is above the B, this forms unstable equilibrium.